Welcome to our comprehensive course on Apache Jmeter performance and load testing. In this immersive learning experience, you'll dive deep into the world of performance testing, armed with the powerful tool Apache Jmeter. Whether you're a seasoned developer, a QA engineer, or a curious learner, this course is designed to equip you with the skills needed to evaluate the performance and load capacity of web applications. Buckle up. Let's explore the world of performance testing together. The concept behind this course is that professional knowledge should evolve from theory to best practices, forming a comprehensive journey. In this comprehensive course, you will learn how to use Apache Jmeter for performance and load testing. We'll focus on practical hands-on exercises, enabling you to master the essential concepts and techniques required to assess the performance of your applications. Whether you're a developer, tester, or system administrator, this course will equip you with the skills needed to ensure your systems can handle real-world workloads. To enroll in this comprehensive course, participants should meet the following prerequisites. Basic understanding of web applications and HTTP protocols. A foundational grasp of web applications and the underlying HTTP protocols is essential. This knowledge will enable participants to navigate the course content effectively and understand the intricacies of performance testing. As we delve into practical exercises and projects, familiarity with Amazon Web Services, AWS, is crucial. Participants should be comfortable with AWS terminology, services, and their functionalities. This familiarity ensures seamless integration of Jmeter testing within an AWS environment. Throughout the course, participants will interact with various tools and platforms via the command line. Being comfortable with command line navigation and execution is necessary for hands-on practice and effective learning. By meeting these prerequisites, participants will embark on a rewarding journey to master Apache Jmeter for performance and load testing. In this immersive learning experience, you'll dive deep into the world of performance testing, armed with the powerful tool Apache Jmeter. Whether you're a seasoned developer, a QA engineer, or a curious learner, this course is designed to equip you with the skills needed to evaluate the performance and load capacity of web applications. Get your hands dirty. We'll guide you through practical exercises, real-world scenarios, and interactive sessions. You'll learn by doing, not just by listening. Our course runs on a state-of-the-art AWS environment, ensuring you experience Jmeter's capabilities in a cloud-native setting. We'll cover the essentials, from setting up Jmeter to creating robust test plans. Exciting news! This frontal course will also be available on Udemy as Jmeter Complete, Part 1, Fundamentals. Now you can learn at your own pace, anytime, anywhere. Buckle up! Let's explore the world of performance testing together. The Jmeter Complete course consists of several parts, outlined as follows. 1. Introduction in Jmeter Setup. Lay the groundwork by understanding Jmeter's purpose and setting up your environment. 2. AWS and Java Linux AMI. Explore the synergy between Jmeter and AWS services, leveraging the power of the cloud. 3. Recording test scenarios. Learn how to record and simulate real-world scenarios for effective load testing. 4. Creating load test plans. Dive deeper into Jmeter's capabilities. Craft robust load test plans that mimic user behavior. 5. Running distributed load testing. Scale up. Execute load tests across distributed environments and analyze the results. 6. Result analysis, advanced topics, and Q&A. Uncover insights from test results, explore advanced features, and engage in interactive discussions. Join us on this exciting journey to become a proficient Jmeter performance tester. Included in the course materials are the following. 1. Course slides and handouts. These resources offer comprehensive coverage of key concepts, methodologies, and practices. They serve as both in-class aids and valuable references for self-study. 2. Sample Jmeter scripts. These practical examples provide insights into real-world applications of the theories taught. They serve as valuable tools for hands-on learning and experimentation. 3. AWS Setup Instructions. Step-by-step guidelines streamline the process of establishing a functional working environment on Amazon's renowned cloud platform. These instructions ensure that students can focus on learning without technical hindrances. Mr. Shai Ginsburg, our esteemed instructor, course creator, and owner, brings a wealth of expertise to this performance and load testing course. With an M.Sc in engineering, Shai has honed his skills as a software, medical, and mechanical engineer. His passion lies in the realm of performance testing, where he excels as an automation and load testing expert. Shai's extensive experience extends to regulatory affairs, making him a well-rounded professional. Since 2008, he has been a dedicated freelancer, offering managed IT services to clients. His approach is laser-focused on achieving business results for his clients, aligning technology with their strategic goals. Shai's commitment to excellence shines through in every aspect of this course. Connect with him on LinkedIn, https://www.linkedin.com/and/Shai Ginsburg, to learn more about his impressive journey and contributions to the field. Course outline: Jmeter Complete Part A Fundamentals and Jmeter Complete Part B Loading. As stated, the concept behind this course is that professional knowledge should evolve from theory to best practices, forming a comprehensive journey. This course consists of several comprehensive sections, each meticulously crafted to provide you with essential knowledge and practical skills. In this foundational chapter, we'll explore the essential aspects of performance testing. 1.1 Demo. We'll kick off with a hands-on demonstration. Through practical examples, you'll witness load testing scenarios in action. This demo provides a tangible understanding of how performance testing works and its impact on software reliability. 1.2 Importance of load and performance testing. Why does load testing matter? We'll delve into the critical role it plays in ensuring software resilience under various conditions. Discover how load and performance testing directly impact user experience, system stability, and overall business success. 1.3 Types of load and performance testing. Not all tests are created equal. We'll explore different load testing methodologies, such as stress testing, endurance testing, and scalability testing. Each type serves a specific purpose, and understanding them is crucial for effective testing strategies. 1.4 Key metrics and KPIs. What do we measure during performance testing? Learn about the essential metrics and key performance indicators, KPIs, that guide our evaluation. From response times to throughput, these metrics provide insights into system behavior and bottlenecks. In this pivotal section, we'll guide you through the essential steps to set up Jmeter on an AWS, Amazon Web Services, environment. 2.1 Launching an EC2 instance. Buckle up as we dive into launching an EC2, Elastic Compute Cloud, instance. We'll walk you through the process step by step, ensuring you have a functional virtual server ready for Jmeter testing. Whether you're new to AWS or a seasoned user, this section will equip you with the necessary skills. 2.2 Installing Java and Jmeter. Next, we'll tackle the installation of Java and Jmeter. These are the building blocks of our load testing environment. Learn how to set up Java, the programming language that powers Jmeter, and install Jmeter itself. By the end of this section, you'll have a robust Jmeter setup on AWS, ready to unleash its testing capabilities. Get ready to explore the cloud and harness the power of Jmeter. In this critical phase of our load testing journey, we'll dive into the intricacies of recording test scenarios. 3.1 Using Jmeter's built-in recorder. Buckle up. We'll introduce you to Jmeter's powerful built-in recorder. Learn how to capture your interactions with web applications seamlessly. This section ensures that you're equipped to record real-world user actions effectively. 3.2 Capturing HTTP requests. Get ready to intercept and store HTTP requests. We'll explore the nitty-gritty of capturing these essential interactions between clients and servers. By mastering this skill, you'll be well prepared for accurate load testing. 3.3 Post-recording operations. Recording is just the beginning. Discover how to refine and optimize your recorded scenarios. We'll cover post-recording operations, ensuring that your test plans are streamlined and ready for analysis. 3.4 Handling dynamic parameters. Real-world applications are dynamic. Learn how to handle dynamic parameters effectively during recording. Whether it's session IDs, tokens, or timestamps, we've got you covered. Get ready to record, capture, and fine-tune your test scenarios. It's time to simulate real-world user behavior. As we delve deeper into load testing, this chapter focuses on creating robust load test plans. Buckle up. We'll guide you through the art of designing user scenarios that mirror real-world interactions. Learn how to simulate user behavior effectively, ensuring your load tests are relevant and accurate. Discover how to configure thread groups to simulate concurrent users, set timers for realistic pacing, and use controllers to organize your test logic. This section ensures your load test plans are dynamic and well-structured. It's not just about sending requests, it's about validating responses. Learn how to add assertions to verify expected outcomes and use listeners to monitor performance metrics during testing. Welcome to Chapter 5. As we venture into the realm of distributed load testing, this chapter equips you with the tools and knowledge needed to scale your performance evaluations. Let's explore the key sections. 1. 5.1 Running Jmeter Load Test. Buckle up. We'll guide you through executing load tests using Jmeter. Learn how to simulate real-world user behavior across distributed environments. This section ensures that your tests are robust, accurate, and scalable. 2. 5.2 Setting up Jmeter in distributed mode. Discover the magic of distributed testing. Configure Jmeter to operate in a distributed mode, harnessing the power of multiple machines. Whether you're testing from different geographical locations or need to handle massive user loads, this section has you covered. 3. 5.3 Creating a master-slave architecture. Dive into the intricacies of master-slave setups. Understand how to orchestrate coordinated testing across multiple Jmeter instances. By creating a master-slave architecture, you'll achieve efficient test distribution and centralized control. Get ready to distribute the load and elevate your testing game. Globe with Meridian's rocket. As we dive into the heart of load testing, this chapter focuses on extracting meaningful insights from your test results. We'll guide you through the art of deciphering performance graphs and reports. Learn how to analyze response times, throughput, error rates, and other critical metrics. By mastering this skill, you'll gain actionable insights into your application's behavior under load. It's time to hunt down bottlenecks. Discover how to pinpoint areas where your application lags or struggles. Whether it's database queries, slow APIs, or resource limitations, we'll equip you with strategies to identify and address these performance roadblocks. Get ready to transform raw data into actionable intelligence. It's where the real magic happens. The actual course begins now, and we've meticulously crafted a structured learning pathway for you. Below, you'll find the detailed content of the course, covering each topic and module. Whether you're a beginner or an experienced professional, this course will equip you with essential skills in load testing, performance analysis, and optimization. Let's dive in and explore the exciting world of performance testing, beginning with the chapters of Part 1 of this course. We hope you'll find this course both informative and beneficial for your job tasks. The title of Part 1 is Fundamentals. Let's begin. Welcome to Chapter 1 of our load testing course. In this foundational chapter, we'll explore the essential aspects of performance testing. 1.1 Demo. We'll kick off with a hands-on demonstration. Through practical examples, you'll witness load testing scenarios in action. This demo provides a tangible understanding of how performance testing works and its impact on software reliability. 1.2 Importance of load and performance testing. Why does load testing matter? We'll delve into the critical role it plays in ensuring software resilience under various conditions. Discover how load and performance testing directly impact user experience, system stability, and overall business success. 1.3 Types of load and performance testing. Not all tests are created equal. We'll explore different load testing methodologies, such as stress testing, endurance testing, and scalability testing. Each type serves a specific purpose, and understanding them is crucial for effective testing strategies. 1.4 Key metrics and KPIs. What do we measure during performance testing? Learn about the essential metrics and key performance indicators, KPIs, that guide our evaluation. From response times to throughput, these metrics provide insights into system behavior and bottlenecks. Welcome to the demo of the Jmeter Complete course. Are you ready to witness the power of Apache Jmeter in action? Join us for an exclusive live demo where we'll showcase the capabilities of Jmeter, a robust performance testing tool that can simulate heavy loads, analyze response times, and evaluate the resilience of your applications. Record test scenarios. See how Jmeter captures user interactions and translates them into powerful test plans. Analyze results. Dive into performance graphs, metrics, and reports to gain actionable insights. Identify bottlenecks. Discover where your application might be struggling under load. The demo is publicly available on YouTube for your convenience. The Performance Testing Lifecycle, PTLC, is a systematic process for carrying out non-functional testing of software systems or applications. It helps identify performance bottlenecks and ensures that the application meets performance expectations. Purpose: evaluate the eligibility of components for performance testing based on risk scores. Identify key scenarios, user load, and response time expectations. Develop realistic user profiles and simulate user behavior. Conduct performance tests in the actual production environment. Monitor real-world user load and system behavior. Remember, PTLC ensures that your application performs well under various conditions, meeting user expectations and business needs. Load testing plays a crucial role in ensuring the robustness and reliability of software systems. Load testing helps us understand how well a computer system or software can handle a large number of users or tasks simultaneously. Imagine a popular website or app facing a surge in traffic. Load testing ensures it doesn't slow down or crash under heavy usage, much like testing a car's performance on a busy highway. By simulating real-world user scenarios, load testing identifies bottlenecks within the system. These bottlenecks could be related to processing speed, memory usage, database queries, or network latency. Detecting these issues early allows developers to address them before they impact end users. Load testing evaluates how an application performs under normal and peak loads. Can the system handle a sudden influx of users during a sale or event? Will it maintain responsiveness during high traffic periods? Are there any resource limitations that need attention? Organizations can make informed decisions about resource allocation based on load testing results. Whether it's server capacity, memory, or network bandwidth, load testing guides resource planning and optimization. Load testing assesses the reliability of a system. It ensures that critical services remain available even when user demand peaks. For example, an e-commerce platform must handle increased traffic during Black Friday sales without crashing. Now, let's discuss the importance of load and performance testing during BFCM. As Black Friday Cyber Monday, BFCM, approaches, load and performance testing become paramount for online retailers. 1. Scalability assurance. BFCM brings a surge in online traffic. Load testing ensures your website can handle the increased load without crashing or slowing down. Scalability is critical to accommodate the influx of shoppers. 2. User experience optimization. Slow load times or errors frustrate users. Performance testing identifies bottlenecks, enabling you to optimize response times. A seamless shopping experience translates to higher conversions. 3. Security validation. Increased traffic attracts cyber threats. Load testing helps uncover vulnerabilities, ensuring your platform is secure during peak shopping periods. For revenue protection, downtime during BFCM can result in lost sales. Performance testing minimizes the risk of revenue loss by identifying and addressing performance issues proactively. 5. Brand reputation. A smooth BFCM experience builds trust. Load testing ensures your website performs flawlessly, enhancing your brand's reputation. In summary, load and performance testing are not just technical necessities, they directly impact revenue, user satisfaction, and brand credibility during the critical BFCM period. Now, let's look just for 1 minute on the realm of performance and load testing from one level above it. Functional testing is a fundamental aspect of software quality assurance. In simple terms, it ensures that each software feature works as intended and produces accurate results. Whether performed by a human testing team or automated scripts, functional testing validates and verifies the software's functionality. Enter non-functional testing, formerly known as NFT, a realm that encompasses various professional considerations, approaches, and techniques for advanced software testing. 1. Load/performance testing. NFT platforms must handle heavy loads during peak trading periods. Load testing evaluates their capacity, response times, and scalability under stress. 2. Compatibility testing. NFTs should work seamlessly across devices, browsers, and operating systems. Compatibility testing ensures universal accessibility. 3. Localization testing. NFTs are global assets. Localization testing verifies their adaptability to different languages, regions, and cultural contexts. 4. Security testing. Protecting NFTs from theft, fraud, or vulnerabilities is critical. Security testing identifies weaknesses and ensures robust encryption. 5. Reliability testing. NFT. Back to the original level of our course, let's delve into the different types of load and performance testing. Load testing, purpose, simulates a specific number of users accessing the application simultaneously. Objective, evaluate how the application performs under normal conditions. Key focus, response times, throughput, and resource utilization. Scenario, imagine Black Friday shoppers all hitting the website at once. Load testing ensures it can handle the traffic. Stress testing, purpose, increases the workload on the application to push it to its limits. Objective, assess performance under extreme conditions. Key focus, identify breaking points, bottlenecks, and system weaknesses. Scenario, intense traffic spikes or sudden resource demands. Stress testing reveals vulnerabilities. Endurance testing, purpose, runs the application for an extended period, hours, days, or even weeks. Objective, evaluate long-term performance and stability. Key focus, detect memory leaks, performance degradation, or resource exhaustion over time. Scenario, continuous usage, such as a social media platform running 24/7. Remember, each type serves a specific purpose in ensuring your application's reliability and optimal performance. Now, let's discuss the essential performance testing metrics and key performance indicators, KPIs. Definition, the time taken for a system to respond to a request. Importance, reflects user experience. Short response times lead to better satisfaction.
Optimization goal, minimize response time for optimal performance.
Definition, the number of requests a system can handle per second. Optimization goal, maximize throughput without compromising response time. Optimization goal, reduce latency to enhance user experience. Definition, the number of errors or failures during testing. Definition, the amount of CPU, memory, and other resources used by the system. Definition, the system's ability to maintain consistent performance over time. Definition, the system's ability to handle multiple requests simultaneously. Welcome to Chapter 2. In this pivotal section, we'll guide you through the essential steps to set up Jmeter on an AWS, Amazon Web Services, environment. Let's explore the key sections. 2.1 Launching an EC2 instance. Buckle up as we dive into launching an EC2, Elastic Compute Cloud, instance. We'll walk you through the process step by step, ensuring you have a functional virtual server ready for Jmeter testing. Whether you're new to AWS or a seasoned user, this section will equip you with the necessary skills. These are the building blocks of our load testing environment. Learn how to set up Java, the programming language that powers Jmeter, and install Jmeter itself. By the end of this section, you'll have a robust Jmeter setup on AWS, ready to unleash its testing capabilities. Get ready to explore the cloud and harness the power of Jmeter. Next, let's explore Amazon EC2 AMIs, the AMI catalog, and how to launch an EC2 instance. An Amazon Machine Image, AMI, is a template that contains a software configuration, including the operating system, application server, and applications. When you launch an instance in Amazon EC2, you specify an AMI. It serves as the foundation for your virtual server. AMIs can be provided by AWS or created by users. They are essential for launching instances with specific configurations. The AMI catalog consists of various pre-configured templates, AMIs, available for launching instances.
10 AMIs servent as starting point for différents use cases, such as web server, database, or custom application.
You can find AMIs in the AWS Marketplace, community AMIs, or create your own custom AMIs. Set instance details like network, subnet, security groups, and storage. Define inbound and outbound rules for network access. Wait for the instance to be ready, then connect using SSH or other methods. Remember, AMIs are the building blocks for your EC2 instances, and the catalog offers a wide range of options to choose from. Bash, short for Born Again Shell, is a Unix shell and command language interpreter. It serves as a command line interface containing built-in commands and has the ability to launch other programs and control processes. Bash allows users to interact with the system by executing commands, scripting, and automating tasks. It is widely used in many Linux distributions and provides powerful features for managing files, processes, and system configurations. The Java Runtime Environment, JRE, is a software layer that runs on top of a computer's operating system, providing the necessary resources for a specific Java program to execute. Let's study the bash commands to install Java and Jmeter on a remote Linux machine. Although this setup isn't suitable for large-scale load testing, it's perfectly fine for developing new scripts or simply practicing. The Java Runtime Environment, JRE, serves as a software layer that operates on top of a computer's operating system.
It provides the essential resource required for a specific Java program to run.
Now, let's explore the bash commands for installing Java and Jmeter on your local Windows machine. 1. Download Java, JRE, from java.com and install it on your Windows laptop or desktop PC. 4. Look into the newly created subfolder jmeter/bin. 5. Run jmeter.bat to launch the UI and work with the application. In this critical phase of our load testing journey, we'll dive into the intricacies of recording test scenarios. 3.1 Using Jmeter's built-in recorder. Buckle up. We'll introduce you to Jmeter's powerful built-in recorder. Learn how to capture your interactions with web applications seamlessly. This section ensures that you're equipped to record real-world user actions effectively. 3.2 Capturing HTTP requests. Get ready to intercept and store HTTP requests. We'll explore the nitty-gritty of capturing these essential interactions between clients and servers. By mastering this skill, you'll be well prepared for accurate load testing. 3.3 Post-recording operations. Recording is just the beginning. Discover how to refine and optimize your recorded scenarios. We'll cover post-recording operations, ensuring that your test plans are streamlined and ready for analysis. 3.4 Handling dynamic parameters. Real-world applications are dynamic. Learn how to handle dynamic parameters effectively during recording. Get ready to record, capture, and fine-tune your test scenarios. It's time to simulate real-world user behavior. Before we begin recording the business process for load testing, let's explore the communication between the web browser, on the client side, and the application, on the server side. This interaction occurs using the HTTP protocol, which serves as the international language of the Internet. Whenever the client communicates with the server, an HTTP request is sent over the Internet. Think of it as an electronic envelope containing an electronic letter. The text written on the envelope is called headers. The content of the letter inside the envelope is called body. Similarly, when the server responds to the client, another HTTP request is sent back over the Internet. Again, it's like an electronic envelope. The text on this response envelope is also called headers. The actual content of the response, the letter inside the envelope, is called body. Understanding this dialogue helps us analyze how information flows between the client and server during web interactions. Now, let's look into the structure of both HTTP requests and responses, including their headers and bodies. The HTTP request is made by the client/browser to the web server. URL. Recording is a highly valuable technique in load test scripting for several reasons. Recording allows testers to capture user interactions with an application without manually writing complex scripts from scratch. It significantly speeds up the scripting process, completing 70% to 80% of the work automatically. During recording, the tool simulates an end-to-end test by capturing requests made during user interactions. This ensures accurate reproduction of real-world scenarios, including various pages, images, and third-party requests. Recording captures dynamic content, e.g., session IDs, tokens, that changes during user sessions. Manually scripting such dynamic values can be error-prone, but recording handles it seamlessly. Recorded scripts create readable reports by distinguishing requests made during different actions. Grouping requests into controllers or transactions helps organize and analyze results effectively. Testers can focus on customizing and enhancing the recorded script rather than writing everything manually. It saves time and reduces the chances of errors. In summary, recording simplifies load test scripting, making it more efficient and accurate. To find the built-in recorder in Jmeter's UI, follow these steps. Right-click on the workbench, located in the left panel, and select Add Non-Test Elements HTTP. Every web browser comes equipped with an F12 development tools set, which allows us to delve into the technical intricacies of web browsing. By simply pressing the F12 key, we gain access to a powerful toolkit. F12 developer tools play a crucial role in modern web development. Understanding and utilizing these tools is essential for composing professional load test scripts. 1. Code inspection. F12 tools allow real-time inspection of rendered HTML, CSS, and JavaScript. Modify code on the fly to diagnose issues effectively. 2. Performance analysis. Detailed insights into page performance, load times, bottlenecks, and optimization opportunities. 3. Network monitoring. View all network requests, API calls, assets, made by a web page. 4. Element reporting. Hover over elements to view properties, styles, and attributes directly.
5. Console access, exécuter JavaScript, log information, and debug script.
These tools empower developers as well as performance and load testing engineers to create robust web experiences and troubleshoot effectively. The Network tab in the F12 Developer Tools, also known as Browser DevTools, is a powerful tool for inspecting network activity when building and debugging web pages and applications. Let's explore its key features. Resource downloads. Ensure that resources, such as images, style sheets, scripts, and fonts, are being downloaded correctly.
API calls. Verificar aquests paràmetres en responses for servici d'API calls.
Performance insights. Understand data download sizes and loading times. Right-click on a web page and select Inspect. In the DevTools panel, click on the Network tab. Each row represents a resource, e.g., an image, script, or API call. After opening the Network tab, DevTools logs network activity. Each row corresponds to a resource requested by the page. Remember, while the Network tab is essential for diagnosing network-related issues, other tools like the Performance tool, Issues tool, and Lighthouse provide additional insights for optimizing overall page load performance. HTTP header fields are a list of line-feed separated HTTP data being sent and received by both the client program and server on every HTTP request. These headers are usually invisible to the end user and are only visible to the back-end programs and people maintaining the Internet system. They define how information sent/received through the connection are encoded, as in accept encoding, the session verification and identification of the client, as in browser cookies, IP address, user agent, or their anonymity thereof, VPN or proxy masking, user agent spoofing, how the server should handle data, as in do not track, the age of the document being downloaded, amongst others. The HTTP connection header is a general type header that allows the sender or client to specify options that are desired for that particular connection. Instead of opening a new connection for every single request/response, connection helps in sending or receiving multiple HTTP requests/responses using a single TCP connection. It also controls whether the network stays open or closed after the current transaction finishes. Keep alive indicates that the client wants to keep the connection open or alive after sending the response message. In HTTP 1.1, by default, it uses a persistent connection where it doesn't close after a transaction. However, in HTTP 1.0, the connection gets closed by default, so if you want to keep it alive, you need to include connection, keep alive in the header. Close, in HTTP 1.0, by default, the connection gets closed after a transaction. However, in HTTP 1.1, you need to include connection, close in the header if you want your connection to close. Note, both directives are also headers that represent the connection in combination. Let's learn more by looking into an example, as follows. The client can specify options for a particular connection using the HTTP connection header. Instead of opening a new connection for every request/response, this header allows multiple HTTP requests/responses using a single TCP connection. It controls whether the network stays open or closes after the current transaction. Connection, keep alive, the client wants to keep the connection open after sending the response. Connection, close, the connection should close after the response is delivered. To check this in action, go to Inspect Element and check the header for the connection field. The header may include other information like access control allow credentials, cache control, and more. Remember that the connection header influences how connections are managed during HTTP transactions. The HTTP headers are used to pass additional information between the clients and the server through the request and response header. All the headers are case-insensitive, headers fields are separated by a colon, key value pairs in clear text string format. The end of the header section is denoted by an empty field header. There are a few header fields that can contain comments. And a few headers can contain quality, key value pairs that are separated by an equal sign. There are 4 kinds of headers context-wise. General header, this type of headers applies to both request and response headers but without affecting the database body. Request header, this type of headers contains information about the fetched request by the client. Response header, this type of headers contains the location of the source that has been requested by the client. Entity header, this type of headers contains information about the body of resources like MIME type, content length. Let's explore the meaning of authentication HTTP headers. Purpose: HTTP authentication is a security mechanism used to verify the identity of a user or client who wants to access a web resource. How it works: when a client, such as a web browser, communicates with a server, the server challenges the client to provide credentials for authentication. www authenticate, sent by the server in a 401, unauthorized, response. It specifies at least one authentication challenge applicable to the requested resource. Authorization, sent by the client in subsequent requests after receiving the challenge. It includes the user's credentials, e.g., username and password, to authenticate with the server. 1. The server responds with a 401 status code and provides information on how to authorize, using www authenticate. 2. The client presents a password prompt to the user and includes the correct authorization header in subsequent requests. Similar to resource authentication, proxy servers can also require authentication. The challenge and response mechanism for proxy authentication is similar to that for resource authentication. The challenging status code for proxies is 407, proxy authentication required, and the proxy authenticate header contains applicable challenges for the proxy. The proxy authorization header is used by the client to provide credentials to the proxy server. If a server receives invalid credentials, it responds with a 401 unauthorized or 407 proxy authentication required status. If valid credentials are inadequate for accessing a resource, the server responds with a 403 forbidden status. Let's explore the meaning of caching HTTP headers. Purpose: HTTP caching is a technique used to improve website performance by reducing redundant data transfer between clients, such as web browsers, and servers. How it works: when a client requests a resource, e.g., an image, stylesheet, or web page, the server can provide instructions on how the client should cache and serve that resource. Cache control, an essential HTTP header that dictates caching behavior. It contains directives that guide how the client, browser, should cache the resource. Expires, specifies an absolute date and time when the resource will expire and should no longer be considered valid. Last modified, indicates the last modification timestamp of the resource on the server. eTag, a unique identifier for the resource, allowing the client to check if the resource has changed since the last request. Faster load times, cached resources can be reused, reducing the need to fetch them from the server. Reduced server load, caching minimizes the number of requests hitting the server. Bandwidth savings, clients retrieve cached content locally, saving network bandwidth. Private caches, tied to a specific client, e.g., browser cache. Can store personalized responses. Shared caches, located between clients and servers, e.g., proxy caches. Responses can be shared among users. No cache, forces revalidation with the server before using cached content. Max age, specifies the maximum time a resource can be cached. Public, indicates that the response can be cached by both private and shared caches.
Private, limiți caching private caches, e.g., browser.
Purpose: conditional requests allow the client, usually a web browser, to modify its behavior based on specific conditions related to the requested resource. How it works: when making an HTTP request, the client can include certain headers that define preconditions. The server then evaluates these preconditions and responds accordingly. If match, used for strong validation. The server will return the requested resource only if its eTag, entity tag, matches one of the listed values. Otherwise, a 412, precondition failed, response is returned. If none match, used for weak validation. The server returns the resource only if its eTag is different from any listed value. If the eTag matches, a 304, not modified, response is sent. If modified since, compares the last modification date of the resource with the provided date. If the resource has not been modified since that date, a 304 response is returned. If unmodified since, similar to if modified since, but the server sends the resource only if it has not been modified since the specified date. eTag, entity tag in opaque string uniquely identifying a version of the resource. It can be based on content or other factors. Last modified date, indicates the last modification timestamp of the resource on the server. Strong validation, guarantees byte-to-byte identity between the resource and the version being compared. Used for critical scenarios like resuming downloads. Weak validation, allows minor differences, e.g., ads, footers, and focuses on content equivalence. Used for performance optimization. Cache validation, helps validate cached. Let's explore the meaning of content negotiation in the context of HTTP headers. Purpose: content negotiation is a mechanism used in HTTP to serve different representations of a resource, such as a web page or an image, to the same URI. It helps the user agent, usually a web browser, specify which representation is best suited for the user. When a client requests a resource via a URL, the server has multiple variants, representations, of that resource available. Content negotiation determines how the server chooses the most appropriate representation to return to the client. Each variant of the resource is called a representation. Both the overall resource and its representations have specific URLs. The client sends specific HTTP headers, such as accept encoding, and accept language, along with the URL. The server uses these headers as hints and an internal algorithm selects the best content to serve. If the server can't provide a suitable resource, it may respond with a 406, not acceptable, or 415, unsupported media type, status. The server responds with 300, multiple choices, or 406, not acceptable, status codes. The client then chooses from the available representations based on its capabilities.
Accept, sans by the client to indicate preferred content type.
User agent, submit is used to request specific representations.
Handling different user agents, e.g., desktop vs. mobile.
Note, over the years, other proposals, like transparent content negotiation, have been proposed but Definition: an HTTP cookie, also known as a web cookie or browser cookie, is a small piece of data that a server sends to a user's web browser. The browser stores this data and sends it back to the same server with subsequent requests.
Purpose, cookie serve several purposes in the web communication.
Session management: cookies help maintain state between multiple requests from the same client. For example, they keep a user logged in during a browsing session. Personalization: cookies store user preferences, themes, and other settings. Websites can customize content based on stored cookie data. Tracking: cookies allow recording and analyzing user behavior. They help track user interactions, such as which pages they visit or items they add to a shopping cart. After receiving an HTTP request, a server can send one or more set cookie headers with the response. With subsequent requests to the same server, the browser includes the stored cookies in the cookie header. The server sets cookies using the set cookie header in its response. Permanent cookies, deleted at a specified date, using the expires attribute, or after a prescribed period, using the max age attribute. Session cookies, deleted when the current session ends, no max age or expires attribute. While cookies were once used for general client-side storage, modern APIs like the Web Storage API, Local Storage and Session Storage, and IndexedDB are now recommended. Cookies are sent with every request, which can impact performance, especially on mobile data connections. Definition: the DNT, do not track, request header indicates the user's tracking preference. It allows users to express whether they prefer privacy over personalized content. When enabled, the browser sends a DNT HTTP header with every request to websites. The header informs websites that the user wants to opt out of tracking for advertising or data collection purposes. The server can then choose whether to honor this preference. Null, no header sent the user has not expressed a preference. History: DNT was proposed in 2009 and implemented by browsers like Firefox, Internet Explorer, Safari, and Chrome. Global Privacy Control, GPC, a newer header that aims to succeed DNT. It aligns with privacy laws like CCPA and GDPR. Use case: users concerned about online tracking can enable DNT in their browser settings. Definition: the content disposition response header indicates how the content should be handled by the client, browser. Inline: the content is expected to be displayed within the browser, as part of a web page. Attachment: the content is meant to be downloaded and saved locally, as an attachment. Serving files for download, e.g., PDFs, images, documents. Controlling whether a resource is displayed directly or saved. Useful for handling file downloads via links or APIs. Remember that D&T helps protect user privacy, while content disposition controls how resources are handled by the client. Let's explore the meaning of HTTP message body information. Definition: the HTTP message body is the data transmitted in an HTTP transaction immediately following the headers, if any. It contains the actual content associated with the request or response. When a client, such as a web browser, sends an HTTP request to a server, the message body carries additional information beyond the headers. For example, when submitting a form on a website, the form data, such as user input, is included in the message body. Similarly, when a server responds with a web page, the HTML content, images, or other resources are part of the message body. Form data, submitted form fields, e.g., username, password. The content type header specifies the type of data in the message body, e.g., text/HTML, application/JSON, image/PNG. The content length header indicates the size of the message body in bytes.
Sending data to a server, e.g. form submissions, API requests. Receiving content from a server, e.g. web pages, images.
Note, the message body is essential for transmitting meaningful data between clients and servers during HTTP communication. Remember that the HTTP message body carries the actual content of requests and responses, allowing data exchange between clients and servers. Let's explore the meaning of HTTP proxies and their associated headers. Definition: proxies act as intermediaries between clients, such as web browsers, and servers. They facilitate communication, enhance security, and provide various services. Sit in front of servers, usually web servers. Forwarded, contains information altered or lost when a proxy is involved. Helps identify the original client IP, host, and protocol. X-forwarded for, identifies the originating IP addresses of clients connecting through a proxy or load balancer. X-forwarded host, identifies the original host requested by the client. X-forwarded proto, identifies the protocol, HTTP or HTTPS, used by the client. Via, indicates the proxy servers involved in the request/response path.
Proxies can expose privacy sensitive information, e.g., client IP.
Remember that proxies play a crucial role in optimizing performance, enhancing security, and managing network traffic. Let's delve into the concept of HTTP request context and the associated headers. Definition: the HTTP request context refers to the environment and details surrounding an HTTP request made by a client, such as a web browser, to a server. Request method specifies the action the client wants to perform, e.g., get, post, put, delete. Request URL identifies the resource or endpoint the client is targeting. Headers, additional information sent by the client, including details like user agent, accepted content types, and authentication credentials. Query parameters, parameters appended to the URL for specific requests, e.g. key1 equals value 1 and key2 equals value 2. Request body, data sent by the client, usually for post or put requests.
User agent identifie the client application, browser, mobile app, etc.
Accept specifies the preferred content types the client can handle. Authorization contains credentials for authentication, e.g., tokens, basic authentication. Referrer provides the URL of the referring page, where the request originated. Handling different content types based on client preferences. Remember that understanding the request context and headers is crucial for building robust and secure web applications. Let's explore the meaning of HTTP security headers and their importance in enhancing web security. Definition: HTTP security headers are additional lines of information included in the HTTP response sent by a web server. These headers provide instructions to the client, usually a web browser, on how to handle the content and improve security. Mitigate risks related to cross-site scripting, XSS, clickjacking, information disclosure, and more. X-frame options prevents clickjacking attacks by controlling whether a page can be embedded in a frame or a frame. And XSS protection helps protect against reflected XSS attacks by blocking page loads when XSS is detected. X content type options prevents MIME type sniffing, reducing the risk of MIME confusion attacks. Referrer policy controls how much referrer information is included in requests. Strict transport security, HSTS instructs browsers to only access the site via HTTPS, improving security against downgrade attacks. Set appropriate security headers based on your application's needs. Use tools like Content Security Policy, CSP, for fine-grained control. Note, while security headers are essential, they are just one layer of defense. Proper coding practices, secure APIs, and other security measures are equally important. Remember that implementing security headers helps protect your web application and its users from common threats. Understanding HTTP request headers and response headers is crucial when scripting bots for web performance and load testing. Let's explore why. HTTP headers provide critical information during communication between clients, such as browsers or bots, and servers. They accompany both requests and responses, conveying essential metadata. Properly configured headers can significantly affect website performance.
Content type, spécifier the type of data being sent, EG, HTML, JSON, image. Correct handling of content type en surproper rendering.
Cache control determines how long resources should be cached by clients or intermediary caches. Proper caching reduces server load and speeds up page loading. User agent identifies the user agent, browser or device. Servers can use this to deliver customized content or track usage patterns. Strict transport security, HSTS ensures secure connections by enforcing HTTPS. Content security policy, CSP mitigates cross-site scripting, XSS, attacks by controlling resource loading. X-frame options prevents clickjacking attacks by controlling E-frame embedding. Different versions of HTTP, e.g., HTTP/1.1, HTTP/2, HTTP/3, introduce new headers and features. Understanding these headers helps optimize performance and security based on the chosen version. When scripting bots, custom headers can be added to simulate specific user behavior. Referrer indicates the source of the request, useful for tracking. Accept language specifies the preferred language for content. When analyzing performance logs, understanding headers helps verify successful requests and identify errors. Headers provide insights into redirects, cookies, and session management. In summary, understanding different headers and their uses is essential for building efficient and secure web applications. By incorporating best practices for header usage, developers can improve performance, security, and user experience. Let's review some examples of request headers and response headers to ensure your understanding. Here's a straightforward initial example. Read it carefully, and make sure you grasp the meaning of each line. Again, understanding HTTP request headers and response headers is crucial when scripting bots for web performance and load testing. Here's a simple second example. Read it carefully, and make sure you grasp the meaning of each line. Keep practicing, and feel free to mail me any questions. While recording with Jmeter's built-in recorder is the standard way to create the initial non-replayable draft of our bot script, we must be prepared for situations where the built-in recorder is not a viable option. This is especially true if we're working in environments that prevent us from altering the proxy settings of the PC where the recording would take place. Fortunately, we have several alternative options to choose from instead of the standard recording process. For example, exporting and importing curl commands. Curl, short for client URL, is a command line tool and library for transferring data with URLs, supporting various protocols like HTTP, HTTPS, FTP, and more. It is widely used for making HTTP requests to interact with web APIs. Now, let's break down the process of exporting requests from the Network tab in the browser's developer tools to curl commands and then importing those commands into Jmeter. Step 2. Open the developer tools, usually by right-clicking on the page and selecting Inspect or pressing Ctrl+Shift+I. Step 3. Navigate to the Network tab within the Developer Tools. Step 4. Perform the actions in your application that trigger the desired API requests, e.g., login, form submission, etc. Step 5. Look for the specific API request you want to export. Right-click on it and select Copy as curl. Step 6. The curl command for that request is now copied to your clipboard. Step 2. Create a new test plan, if you don't have one already. Step 3. From the Tools menu, select Import from curl. Manually, paste the curl command directly. To record a Jmeter script from a mobile device using a MITM, man-in-the-middle, proxy, follow these steps. Go to Settings Wi-Fi, select your connected network. Add the server value, your computer's IP address, and the desired port, e.g., 8888. Go to Settings Wi-Fi, select your connected network. Show advanced options and choose Manual from the HTTP proxy section. Add the proxy hostname, your computer's IP address, and the desired port, e.g., 8888. Right-click on Test Plan, go to Add Non-Test Elements HTTP/S Test Script Recorder.
Set the port to 8080 or any available port.
Click Start. This will start the Jmeter proxy on localhost. Perform actions on your mobile app that you want to record, e.g., navigate through screens, submit forms. Jmeter will capture the HTTP traffic between your mobile app and the services it communicates with. In Jmeter, you'll see recorded requests under the HTTP/S Test Script Recorder. These requests form the basis of your Jmeter script. MITM Proxy is an excellent open-source tool for intercepting and analyzing network traffic. It works well for both rooted and non-rooted Android devices. Set up your mobile device's Wi-Fi proxy settings to point to your computer's IP address and port. Default is 8080. Install MITM Proxy's certificate on your mobile device to capture HTTPS traffic. Start MITM Proxy and let it run in the background. While Jmeter recording may seem challenging at first, the good news is that it becomes easier with practice. However, recorded scripts require post-processing to convert elements like timestamps, session tokens, lengthy strings, and non-constant parameters into dynamic variables. This ensures your scripts are reusable, maintainable, and create robust and realistic bots. So after recording your test scenarios using Jmeter's Test Script Recorder, or any other workaround recording, there are several post-recording operations you must be performed to enhance your load test script. Before proceeding, validate the recorded script to ensure that all requests were captured correctly. Use the View Results Tree Listener to inspect the recorded requests and responses. In the thread group, set the following parameters. Loop count, set the number of iterations for each user. If certain request parameters are common across all pages, e.g., authentication tokens, add them to the HTTP request defaults element. Delete any requests that are not relevant to your test scenario. Replace hard-coded values, e.g., user credentials, session IDs, with variables. Use Jmeter's built-in functions or extract dynamic values from responses using regular expressions or JSON extractors. Include assertions to validate the correctness of responses. Ensure that expected content, e.g., specific text, status codes, is present. If your application relies on cookies or maintains sessions, ensure that Jmeter handles them correctly.
Use extractor to capture and reuse this value.
Grow relatar requests using controllers, e.g. simple controllers, logic controllers.
Include listeners, e.g., view results tree, aggregate report, to monitor test execution. If running distributed tests, set up remote servers and configure the remote start option. Export it for execution on remote servers or cloud-based load testing services. Remember that load testing is an iterative process. Continuously review and refine your script based on test results and application behavior. Let's describe how dynamic parameters are handled in the context of load test scripting. Dynamic parameters are values that change during the execution of a web application. These can include session IDs, CSRF tokens, timestamps, and other unique identifiers. In load testing, handling dynamic parameters is crucial to simulate real-world scenarios accurately. Correlation: identify dynamic values in responses, e.g., session IDs, and extract them using Jmeter's built-in extractors, regular expressions, JSON path, XPath. Parameterization: replace hard-coded values with variables. Use CSV files, databases, or Jmeter's built-in functions to provide dynamic values.
Session management: maintain sessions that be handling cookies, tokens, and authentication.
Think time: introduce delays between requests to simulate user think time. Login request: capture the session ID from the login response and use it in subsequent requests. Search request: parameterize search queries to simulate different users searching for products. Checkout request: handle cart IDs, product quantities, and payment details. For tools, Jmeter provides built-in elements, CSV dataset config, regular expression extractor, to handle dynamic parameters. Remember that understanding your application's behavior and identifying dynamic values are essential for successful load testing. Regex, regular expressions, plays a crucial role in load testing by helping you handle dynamic content in your test scripts. Here's how. Extracting dynamic values. During a load test, some elements like session IDs or timestamps in the server response will change with each request. Regex allows you to extract these dynamic values from the response and store them in variables. These variables can then be used in subsequent requests, making your script reusable. Parameterizing requests. Load tests often involve sending multiple requests with slightly different data. Regex helps create patterns that match specific parts of the data you want to vary. You can then use these patterns to automatically generate unique data for each request, simulating realistic user behavior. Validating responses. Regex can be used to verify the expected content in the server response. You can define patterns that match specific elements like success messages or error codes, ensuring the application behaves as intended under load. Overall, Regex helps you create more robust and adaptable load testing scripts by managing dynamic elements and ensuring your tests accurately reflect real-world user behavior. Regex, regular expression, is a sequence of characters that define a search pattern. Usually, this pattern is used by string searching algorithms for find or find and replace operations on strings, or for input validation. Regular expressions are used in search engines, search and replace dialogues of word processors and text editors, and in testing tools. You should use regex101.com whenever you're working with regular expressions, regex, and need help with the following. Building regex patterns. Stuck on how to write a regex pattern to match what you need? Regex 101 provides a user-friendly interface to build your pattern step by step. Testing and debugging regex. Think you've written the correct regex, but it's not working as expected? Input your pattern and some test text into regex 101. It will highlight matches, show captured groups, and pinpoint any errors in your syntax. Understanding regex. Regex can be cryptic. Regex 101 offers real-time explanation as you build your pattern, helping you understand what each part does. There's also a cheat sheet for various programming languages to see how regex translates across different environments. Learning regex, new to regex? Regex 101 has a built-in tutorial to get you started with the basics. You can also experiment with pre-built sample patterns and text to get a feel for how regex works. 2. Enter your regex pattern in the top box. 3. Input the text you want to test the pattern against in the bottom box. 4. Click the Matches button to see how your regex interacts with the text. 5. Regex 101 will highlight matches, captured groups, and any errors. 6. Use the explanation panel and cheat sheet to gain insights into your pattern. By leveraging regex101.com, you can save time and frustration when working. A regex cheat sheet is a handy reference guide that summarizes the common elements and syntax used in regular expressions, regex. Here's how to effectively use one. Asterisk, what do you want your regex to achieve? Are you extracting data, validating format, or searching for specific patterns? Asterisk, knowing your goal will help you focus on the relevant sections of the cheat sheet. Asterisk, literal characters. These simply match the character itself, e.g., A matches the letter A. Asterisk, meta characters. These have special meanings within regex, e.g., dot matches any single character except newline. Asterisk, character classes. Define a set of characters you want to match, e.g., AZ, matches any lowercase letter. Asterisk, quantifiers. Specify how many times a preceding element can be matched, e.g., X asterisk matches 0 or more X characters. Asterisk, look for the symbols or abbreviations that represent the functionality you need. Asterisk, for instance, if you want to match any digit, you'd look for \d in the cheat sheet. Asterisk, cheat sheets often show examples of how these elements work together to create more complex patterns. Asterisk, many cheat sheets also link to online testers like regex101.com, https://regex101.com/ https://regex101.com, where you can experiment with your patterns and see the results in real time. Asterisk, pay attention to flavor. Regex syntax can vary slightly between programming languages and tools. Asterisk, start simple. Don't try to build complex patterns right away. \w is word characters, A to Z, capital A to capital Z, 0 to 9 underscore. \d is digits, 0 to 9. \s is, \f, \t, \n, \r, form feed, tab, new line, carriage return in space. \w is the complementary of \w, caret \w. \d is, caret \d. \s is, caret \s. The letter A with a question mark means a pattern of 0 or 1 characters. The letter A with a plus means a pattern of between 1 to infinite characters. The letter A with an asterisk means a pattern of 0 to infinite characters. The letter A, n, m, means a pattern of between n to m characters. The letter A, n, means a pattern of between n to an infinite number of characters. The letter A, n, means a pattern of exactly n characters. Pipe is alternation, also known as logical OR. Ellipsis is grouping and capturing. /I is case-insensitive pattern matching. \A is beginning of string. \Z is end of string, or before new line. \Z is end of string. Exploring a realistic scenario, refining the regex pattern. Consider a practical scenario where our load testing bot needs to locate a link to the print page on a specific web page containing multiple references to various links. Our initial regex pattern was overly broad, resulting in the successful matching of 8 HTML pages. However, for precise navigation, the bot requires a single, exact address for its next step. Let's fine-tune our approach to achieve the desired outcome. During the second attempt, the regex pattern identified a single large match instead of the specific individual link. It's important to note that the regex pattern was anchored to the word printable, which prominently appears on the test web page. Let's refine our approach to achieve the desired outcome. After 3 attempts, the regex pattern finally hit the mark. It effectively filtered out irrelevant links from the test web page, while remaining anchored to the specific print web page. The problem has been successfully resolved, and our bot can now extract the correct link and autonomously navigate to the print.html page. Great work! If you may have any questions or need assistance, please feel free to reach out to me via email at skinsberg@gmail.com. I'll be happy to help. Looking forward to your questions and feedback. Congratulations on completing the first part of our Jmeter Complete course. In this foundational section, you've gained essential knowledge about Jmeter's core concepts, test plans, and performance testing basics. As we move forward, remember that strong fundamentals pave the way for advanced skills. Stay curious, practice, and explore the exciting world of performance testing. Looking forward to our next learning journey together.